Hello everyone. So we will start with priority algorithm with the previous data itself, because this was again asked in the previous question paper and the model question paper with the same thing, but only we had a priority column that was given extra. So here in the previous question paper and the model question paper, when they have given to solve as the priority algorithm, they have just asked to solve it according to priority algorithm. Sometimes they have asked to solve according to preemptive priority method, and sometimes only just a priority algorithm. And they have not even given the conditions whether to take the priority lesser the number or higher the priority, or higher the number lesser priority. So before solving such questions, you should first write in the exam paper that I am solving non-preemptive method with the condition lesser the number, higher the priority. Now here I will take the condition lesser the number, higher the priority for both preemptive and non-preemptive method. Okay, so here for priority algorithm, I will take the condition lesser the number, higher the priority. Okay, that means if the number is less, then this process, that is P3, has the highest priority. Then next priority is being given to P2, then next for P1, at the end P4. This is how your priority will work. Now coming to the next, first we will solve the non-preemptive method. Okay, for non-preemptive method we will be solving. Now here for the non-preemptive method, we know that once if the process has been scheduled, then it will be completely executed. There will be no interruption while it is executed. Correct? So first thing we have to do is your Gantt chart. Now when I start with your Gantt chart, I obviously have to start it with 0. So at 0, we know which is the process that is arriving. So at 0, we have process P1 that is arriving. Okay, now here, though the priority is 3, I have to schedule process P1. Why? Because there is no any other process that has come at time 0. Okay, so we have to solve process P1 for the execution, though the priority is 3. Now as this is non-preemptive, I will be executing it completely. So it will be, the execution time is 9 seconds or 9 minutes, whatever it is. So it will be till 9. Now next we have to see at from 0 to 9. We can observe that at 1th second here, process P2 has come. At 2th second, we have process P3 that has come. At 3rd second, we have process P4 also that has already come. So in my ready queue, we have all 4 processes that are ready for the execution. Now we can check who is having the lesser number so that I can consider those as the highest priority. Now P1 is already done. Okay, so we are not considering P1 process for the execution further. So we have P2, P3 and P4. As per the condition, lesser the number, higher the priority. We can see 2, 1, 4. Who is having the less number, or which is the least number? It's 1. So when I say this is less number, so the process P3 will be having the highest priority. So now process P3, when I execute, it will be executing completely because I am solving non-preemptive method. So we have 9 plus 4, that is its burst time is 9. So it is 9 plus 9. So it is 18. Now we have done with P1 and P3. Remaining is P2 and P4. Again we have 2, which is a lesser number than the 4. So process P2 will be given the highest priority. So P2 will be executing for next 4 seconds, that is till 22. The remaining process is process P4 with the burst time 5, that is 27. So I hope the Gantt chart for your non-preemptive is as simple as your FCFS. So here again, calculating completion time then turnaround time and waiting time. You need not consider response time, because response time is usually not asked, but only once it was asked in one previous question paper. So I have just made you solve how your response time can be calculated. If it is that, you can check with the previous videos and calculate here also. So we have a completion time for P1 till 9 seconds, P2 till 22 seconds, P3 we have till 18th, then P4 it completed at 27. Now coming to the turnaround time, it's nothing but completion time minus arrival time. So make sure you write all the formulas somewhere when you are solving, so that your evaluators know that you have solved it according to the formula and it's correct, so you know something about it. Now coming to waiting time, the formula is turnaround time minus the burst time. Okay, so now turnaround time will be completion time minus the arrival time. So it's 9, it's 21, it's 16, then 27 minus 3, that is 24. Now coming to the waiting time, we have turnaround time minus the burst time. So it's the 21 minus 4, then we have 16 minus 9, 24 minus 5. Okay, so this will make your waiting time. So to calculate average turnaround time, now it's simple. You know how to calculate the average, add and divide by the number of processes that are there, that is divided by 4. So you get something around 17.5. Again, I'm keeping this as unit, though, because it is not mentioned with milliseconds or seconds or whatever it has been asked for. Then the next we have average waiting time. So you are just calculating by addition of all waiting time divided by the number of processes. So you know how to calculate the average. So it comes around something 10.75 unit. Now again, I'm writing here it as unit. You can mention whatever the unit has been given. So I hope your priority algorithm with the non-preemptive method with the condition lower the number, higher the priority is clear. Now next we will be seeing the preemptive method. Okay, so next, that is with the non-preemptive method. So here also we have solved with non-preemptive, sorry. So we will be solving it with preemptive method. Now here we can see again I have taken the condition lower the number, higher the priority. So whenever they have asked just to solve the preemptive algorithm but they have not given you any method, what to do in that case? We have to check with the marks. If the marks is being asked for 10 marks and they have just asked to solve the priority algorithm, then you have to solve both the methods of non-preemptive and preemptive. If they have asked along with some other uh, algorithms, then check with the marks and solve the method. It is better to have solved with the both the methods instead of solving only one method. But you have to please keep, you can judge it according to your marks and the time consumptions. Okay, so if you solve it many times, you will be perfect so that you can solve both the methods in the exam. Because in the OS paper usually we have less time. We feel, the students feel that it's a very lengthy paper as it's a bit of theory and bit of problems. So it's better to solve the problems first if you are very well known and you're perfect in that. Okay, now coming to your preemptive method, we have the condition lower the number, higher the priority. So first we will be plotting with the Gantt chart. Okay, so your Gantt chart will be with preemptive method. So you already know that for preemptive method we can forcefully remove the process that are executing. While it is executing, we can remove. Now at 0 we know there is only one process that has come, that is process P1. Now as it's preemptive method, I will be going 1 seconds. Okay, so that I have to see which process has come in that, and I can forcefully make that process execute now than the previous. Now process P2 has come at 1 second. Now in your priority we have to check which process among P1 and P2. There is only two processes that has come in the ready queue now. So which among these processes have the highest priority? We have the condition lesser the number, higher the priority. Among 3 and 2, who is having the less number? That is 2. So process P1, P2 have the highest priority. So I will be scheduling process P2 till the second. Okay, now at second we have got P1, P2, P3 in our ready queue. Now among these three, who is having the highest priority? Now less number, higher priority. So process P3 has the highest priority among these three. So I will be taking process P3. Now at third second. Okay, now at third second, process P4 has come. Now you can check that all the processes have come in the ready queue and who is having the highest priority. That is P3 itself. So at 3 again I will be scheduling P3 only. Now you can observe that till 4th second I can execute here, but again go till 5th second. You can go second wise. As I said in your previous round robin also, you can go second by second, but the problem is it might go a lengthier Gantt chart along with the complexity to solve the next problem. I mean next part of your problem. So it's better once you know that till third second I have all my processes in the ready queue, then you start solving it according to your non-preemptive way. Now we have at fourth second no any other process, so I will execute P3 completely. Now you have already observed that at 2 to 3 I had my P3 executing for 1 second, so it was 8. Now here also P1 was executed for 1 second, so it will become 8. Now P2 had executed for only again 1 second, so it was becoming 3. Okay, so now P3 I will execute it completely. So how much it will be? 3 plus 8. Okay, so it will be till 11. Correct. So you can go from 2 to 11 also directly if you are able to think the next. That is also no harm in your Gantt chart. You can go at second wise also. Okay, so now I'm done with process P3. Okay, so there is nothing that is left to execute in P3. Now remaining is P1, P2 and P4. Among this, who is having the highest priority? It's the process P2. Now we already know that all our processes have come in the ready queue. So now process P2 is left with 3 burst time, that is one has already been executed, so I'll execute it completely. That is, I have already told, once you have everything in your ready queue, you can then solve it according to your non-preemptive method. So it will be till 14. Now coming to the next, we have done with the P2, we have left with P1 and P4. Who is having the higher the priority? It's a less number, higher priority. So P1 has the next highest priority and it is left with 8 execution time. So 14 plus 8 is 22. Okay, now remaining, that is P4. So we have to schedule next is your process P4 with the burst time 5. So 22 plus 5 is 27. Here you can observe in all the algorithms we have got 27 itself. So that means your Gantt chart is correct to up to something, say about 50%. But if you know that there is nothing that is left like this, then it's correct. Okay, okay, now coming to the next, we have to calculate your completion time, turnaround time and waiting time. Again, it's better to write the formulas in some part of your solving of the problem, so that you are also not confused and even the evaluator knows that you are done with the correct formulas. So here the completion time for the process P1 comes at 22 but not 1, because it still was remaining for the execution. So I will take 22. Now coming to the next, that is process P2 has completed it at 14 but not at 2. So I'll write it as 14. Okay. Now next we have process P3 that completed at 11. Then process P4 completed at 27th second. Now again applying the formula for the turnaround time, we have completion time minus the arrival time. So it will be 22 for P1, for P2 it will be 13, for P3 it will be 9, for P4 it will be 24. That is 27 minus 3, 11 minus 2, 14 minus 1. Now coming to the next, that is waiting time. We have turnaround time minus the burst time. Now here we have to see the original burst time only but not the updated one. Okay, so this updation was only regarding for your Gantt chart. So it is 22 minus 9 but not 22 minus 8. Okay, so 22 minus 9 is 13. Then 13 minus 4, that is 9. 9 minus 9 is 0. 24 minus 5 is 19. So this makes your waiting time. Now then we have to calculate your average turnaround time. So average turnaround time can be calculating by adding all the turnaround times plus 9 plus 24 divided by number of processes. So you get something around 17 unit. Again you can cross verify. Okay, now then next we have average waiting time, that is this column should be added and divided by the number of processes that are there. So you get something around 10.25 unit. So it's better to write the measurement, that is unit or the seconds or milliseconds or whatever. So I hope your priority, non-preemptive and preemptive methods are clear. So this which we solved was preemptive method. Okay, so I hope it is clear. If you solve for the more problems, you will be perfect in such problems. And please do share and subscribe for more videos. Thank you so much.